Now, join me in welcoming Dr. K. Suresh, a seasoned technologist and senior software engineer currently working at Dataflow, where he specializes in data engineering, scalable ETL pipelines, and cloud based data solutions. With 4 years of industry expertise and over 11 years of academic experience, he has worked extensively on modern data platforms involving AWS, DBT, Apache Spark, Snowflake, Postgres, Fivetran, and Airbyte. Dr. Suresh holds a PhD in computer science and engineering from Satyabama Institute of Science and Technology with research focused on automated brain tumor detection and volumetric rendering of MRI studies. His career also includes significant contributions to institutional software development, mentoring award winning student projects, and conducting training sessions in data science, machine learning, and web technologies. We are honored to have him with us today and look forward to the valuable insights he will share from his rich experience in both industry and academia. We welcome you, sir. Kindly take over the session now.
Thank you, Teresa, ma'am. Hope all of you are doing good. So thanks for the introduction. So I was worked in an engineering college for 10 years, and right now I switched to company. So here I'm concentrating more on Java, Python, and newest GenAI technologies. Okay, so let's we enter into the session. I'll share my screen.
Sir, your voice is not audible, sir.
It's audible, it's audible.
Okay. So is my screen shareable? Is
Yes,
it
sir.
viewable?
Yes,
Okay.
yes, it's visible, sir.
Yeah. So fine, folks. So the topic given to me is about so MONAI, so which is deep OpenAI framework, which is used extensively for medical image segmentation and other processing. So let's we dive more into MONAI. Before that, we just come to know about what is PyTorch framework. Okay, so using this framework only, we can make use of MONAI framework so that we can apply medical imaging segmentations and processing of medical images. Okay, so this PyTorch framework is basically from the Python framework, which is extensively used in deep learning frameworks like we will be aware of some CNN, convolutional neural networks, and RCNN and all. Okay, so using this framework, we can make use of all the deep learning frameworks, and we can apply it to any newest technologies of Python, and we can make use of the ecosystems like MONAI and all in PyTorch framework. So here in this PyTorch, we can so this is the first framework which is exclusively used for this medical AI research and production. Okay, so PyTorch is the base. So in the base framework,
Excuse me, sir. Sir,
yeah,
sorry for interrupting.
yeah, ma'am.
Can you put in slideshow, sir?
Is it okay, ma'am? Now?
Yes, thank you, sir.
Okay, okay. Okay. So PyTorch is the base framework. So we can apply any sort of ecosystems on top of it. So these are the ecosystems like the PyTorch framework. So we have Torch Vision, which is for image processing, and Torch IO and MONAI for medical image processing. And MONAI is we have some trained deep learning models inside. So we can make use of those models also. So in this MONAI framework. And then we have like PyTorch, Lightning, and all for the training groups. Okay, so this PyTorch framework we can easily integrate it with the DICOM and Nifty frameworks. So DICOM is a kind of image format. Like you can take any lung study or a brain study of a particular patient. We can have like some 50 slices. It starts from left. Say if we take brain imaging, brain MRI imaging, so it starts from the forehead and then it scans up to the back. So the number of slices depends. So we can take 500 slices, or you can simply take 15 slices. It all depends. So each slice represents an image, and it has some width, height, and then the pixel depth. So three information will be there. So for each DICOM slices. So for one particular patient study, the slices are set. So we can use scaling, interpolation, so that we can increase the number of slices and so on. So this is one type of file format is DICOM, and the another one is Nifty. Okay, so these formats are available. Some datasets are available in the internet. You can directly make use of. So then we get into MONAI. So it's an open network for AI. So it's an open source, and it is in PyTorch framework. Okay, so so in MONAI framework we can have it has some many deep learning models inside, which is already built and trained. You can make use of the models and you can apply. So it is already trained, so you can test it with your new images and you can find the similarity scores. So this MONAI framework is optimized for MRI, CT, and X-ray. It supports data loading, big processing, and final deployment. So in MONAI, we have a final thing called MONAI deployment. So this deployment, we can directly deploy this particular application to hospitals and the required industries. So this is developed by this NVIDIA. So it is a graphical thing, right? So NVIDIA and the MONAI community. So this MONAI is nothing but you have some many deep learning models are inside. You can make use of the models and you can apply it for your test set of images. So it is domain optimized, exclusively for healthcare imaging. So it produces reproducibility, and it integrates with PyTorch, as I already mentioned. And then I said about the MONAI deployment, right? It can be deployed to hospitals, and then so it has some things like networks and losses and metrics. Like many networks are there, as I said, with the deep learning networks. Like so, what network we are going to use? Okay, so the network we have to choose is, and then the losses like some ground truth information will be getting, right. So with the ground truth information and the image segmented results, so we can find the loss, how much loss we are getting. Like dice similarity is a similarity kind of loss, and we have other metrics like Jacquard, the true positives, negatives, right? So that can be done by this. Okay, so these are the major items which is in the MONAI framework. Okay, so in MONAI, the first, how you pull in the data. Okay, like we have data sets, and you make use of those data sets. Like we can set the data sets as a cache data set, which is it caches the data from the memory. Okay, so that is cache data set. And we have the other type of data set is a smart cache data set, which is nothing but when you are training one particular data set, right? So it will shuffle the images inside the data set. So that is the smart cache data set. Okay. So and then we have transforms and IO utilities also in data. So data transformation, like resizing, so that can be done. Okay. So and then networks. So what networks we can make use of it? Like you have UNet network and the segmented resistant network and the dense network. Okay, it depends on the your image, or depends on your the type of image, whether it is a DICOM or Nifty or so on. And we can, using this MONAI framework, you can find out, as I said, the dice laws and the focus laws. So dice laws, as I said, so both of that is nothing but the image similarity thing. The finding out the true positives, negatives, and all, and it is compared against the ground truth. Okay. So these are the some distance metrics like dice metric, Hausdorff distance metric. So other metrics can also be calculated using this MONAI architecture. And then it is integrated with MONAI label, MONAI deploy, and MONAI generative. And these are all not comes under the open source version. And so it is easily integrated with these platforms. Okay. So how this workflow happens, like how to load data into the MONAI framework, and finally how we are getting the results. Okay, so first load the data. I'll come up with one practical application of loading a data set, and then so how to perform a series of steps like so. These are the workflow steps. Okay, the first step is to load the images, and the second step is about the pre-processing. Okay, so whether you want to resample or you want to interpolate images and so on. And then you just build a neural network, or you make out the existing network, whatever, and then calculate any loss against the ground truth, and then evaluate metrics based on some dice score. Okay, and how to deploy it. Okay, so we'll see this in a step-by-step manner by make use of a Jupyter notebook. I'll share you the notebook. First, I will show you the data set, what it comprises of. I have taken a lung data set. Okay. So which is in the folder lung data. And I have two folders, one is image and another one is masks. So these are the actual lung images, that is the CT images of lung. Okay, so I have just taken some 12 images since I'm using my own own Colab integration. So I want to make use of minimum training and minimum testing. Okay, so so in those image folders you can have many files. Okay, based on your runtime environment. Okay, I just for a practical thing I'm using only 12 images. So these are all the train images or validate images. Okay, so that will be partitioning into these images into training images and validate images. Okay, too. And then you have the mask data. Okay, so the lung mask which is given by the radiographer. Okay, or so it acts as the ground truth. Okay, so that we can find the similarity scores and also find the losses. Right. Okay, so inside lungs data we have two folders. One is the actual images of the lungs, and the next thing is you have the masks, okay, which is given by the radiographer. Okay, and also check like the file names. Okay, this is CXR mask underscore 19.048. So which is same as, see the first image, CXR image underscore 19.048. So these two images should be same, and the naming also should be same. Then only it will work perfectly in MONAI. Okay, so these 12 images should be named Okay, so this is image. This see the numbering, right? 19048. The same way it should be numbered like this way. Okay, so this is mask and that one is image. Okay. So this is the data set we have taken. Okay. So these are all the libraries to be installed. So before using Torch and before using MONAI, so what I'm using is I'm using of the Python libraries like Torch and MATLAB lib and NI Babel, MONAI, everything. Okay. So in your Colab, open a new Colab Jupyter notebook. Okay. And if you execute this steps sequentially, then obviously you'll be getting the output. Okay. So I'm importing the classes from each library. Okay. So I'm making use of all the matplotlib, and then I'm using the MONAI unit network, and I'm making use of dice metric, dice loss metric, everything, right? So this is all about my the importing the libraries. Okay. So I've shown you the lung data folder, right? So this lung data folder, I have just zipped it. Okay. And I attached to my Google Drive. Okay. So this is my Google Drive ID for the particular zip file. You can see, right? So this is the ID of the file. Okay, so drive.google.com. So the ID of the file. So if you so where you can get this ID is you have to upload this particular zip file into your Google Drive, and then you can click the share link, right, which is present in the Google Drive. So there you will be getting the copy link. So in the copy link you will be getting this file ID, and you just give the file ID over here so that it will extract the lung data, right, the zip file from the drive. Okay, so I'm loading the zip file from there. So from the zip file, right, you can see I'm providing the URL. The file name is lungdataset.zip. I'm extracting it, and finally, so once I run this particular set of code, it will show you the dataset extract. Okay, so totally the size of the file is 1.6 MB. Okay. So and then once it's imported, right? So we have to find in which directory that our data is residing. Okay, so for that, just go through this. So I have this, right. So what is nothing but your drive information, your current drive information. That is where you are running the Colab environment, right? Okay, just check with the content lung data. So where it is residing. Okay, it will show you. Like, so these are the images, right? So the content lung data images, you'll be having all the images, and in the masks, you'll be having all the mask images. So these two folders are extracted in this location, like content lung data images. Okay. So I'm setting this as my image directory. Okay, I'm setting the path for the images folder as well as the mask folder. Okay. So once I done, it has to be sorted, right? So even if your files are not in the sorted manner, like we have said, right? So 19048, and the next image will be 19049, and so on, right? So totally 12 files are there. So it has to be sorted and loaded in image files. Okay, the image files variable, which is nothing but an image list. Okay. So once I print this image files and mask files, so I'll be getting 12 images and 12 masks. Okay, the total number of files. Okay. So and then I'm making like the ground truth, that is the mask images, right? So I'll show you the size. The size also matters. So it should be 512 cross 512. Okay. So since it's a grayscale image, right? The pixel intensity values will be from 0 to 255. Okay. Also, make sure the masks also has the similar dimensions. Okay, like 512 cross 512. So both are 512 cross 512. Okay. So I'm finding out. Seems like you can see here, right? So this image, it seems like only two classes, right? Like black and white. Maybe we are having only 0 and 255, but we can find out through the code, like, so totally how many classes are there? Okay, because MONAI needs the number of classes which is used for masks. Okay, so what I'm doing is I'm iterating all the mask images. Okay, I'm just converting into a grayscale. So if you give L, then obviously that particular image will be converted to grayscale, and then so all the images are placed in this array. Okay, so I'm just converting the images into a NumPy array. Okay, it's nothing but an integer values. Okay, so I'm calling the scan labels function with I'm passing all the mask files which I have extracted here. Okay, the 12 files of from the mask directory. Okay, so I'm getting the number of classes. Okay, the total detected number of classes is 204. So this is not from the image file, and this is from the mask file. Okay, so seems like it has only two classes, like 0 and 255, but in this case it is not actually 0 and 255. Okay, it has a series of values. Okay, you can see here, right? So it seems like it has 0 to 255, but the total values is 204. Like we have in between, some of the values are missing in that also, because here I'm finding the unique values, not all the values. Okay, so unique values means it shows what are the unique values present. So it seems like starts from 0 and ends with 255, but in between we have some missing values also, the mask images, right? So you can see 79 here, and then no 80, and then we have 81. Similar way, we have 27 here, and no 28, and then 29, and then from 30 to 34 is not there. Okay, so total classes are some 204, and then we have the total, the intensities, right? It starts from 0 to 255 since it's a grayscale image. So we are first detecting the number of classes. Okay, 204, and then I'm mapping the image with the mask. Okay, so I'm iterating both image files and the mask files, and map it with image and label. Okay, and you can see here, right? So it's like a dictionary object, like the key is image, and the value is the path of the first file, which is in the image directory. Similar way, the next key value, this is one object, right? See, this is the one object. I'm just printing the dictionary's first object, that is data x of 0. So this is the entire object, and here we can see the first key is image and the image path, and the second key is label, and we'll be getting the mask path. Okay, so we just mapped image and the mask file together to a data dictionary. Okay. So and then, so I'm right now I'm making use of the MONAI libraries, like see we have so I'm creating some a mapping task. Okay, so why I'm doing this, as I already said, we have values between 0 and 255, and in between we have some missing values also. Okay, so we have to map the image and the mask. Okay, so we have some missing values also, right? So that should be mapped with the exact value. You can see here. So these are the values you can see up to you can see 18, 23, some 26, 27. Okay, so up to this, the image intensity is mapped with the mask intensity. So, and then you can see, right, for 28, okay, we don't have the mask intensity because we don't have 28 here. So for the image value 28, so the mask value 29 is applied. Similar way for 29, 35 is applied. So like that, it goes on. So why we are performing this is, so finally you can see, right, we have 255 values which is in the image, and 203 is the last value which is, so 203 is the value which is, because totally 204 values are there, right? You can see here. The total number of classes is 204. So the final value 204 is mapped here. Okay. So this is the value to index mapping we are performing. Okay. So once it's done, because these pre-processing has to be done before processing the image, right? Okay. So and then I'm splitting here like train transforms and the value transforms. Yeah. So the previous libraries like the MONAI framework, we don't have this D. So right now in the newest version, they have added before that we'll be having only a load image, ensure channel first and all. So right now in the new the updated libraries, we have D at the last. Okay. So this is about the train transforms. Like we are just splitting. We have totally 12 files, right? So we are splitting into train transforms and the value transforms. So some images for training and the some images for validation, right? So in the train transforms, we are picking all the files. Okay, so we are making some image pre-processing, like I'm resizing those images like 5 cross 12 to, right, 256 cross 256. Okay, so similar way I am doing some sort of pre-processing steps so that we'll be getting the visualization better, right? So the first thing I am doing for train transforms for images, and then for the for both images and masks. Similar way, I'm performing validate transforms for both images and maps. Okay. So once this transform is ready, okay, so I'm just splitting the training files and the validate files. Okay, you can see I'm making use of the percentage, right? So like 0.8. So what is 0.8 of 12? It's nothing but 9. So 9 is for training. Okay. So we are given this column, right? Okay. So this takes 9. So from 12. Okay. So 9 is for training and the 3 is for validation. Okay. Since the data set is very small, then so only 9 files for training and the 3 files for validation is performed. And then I'm using the cache data set because I want to put everything from the RAM to cache so that it improves the performance of training. Okay. And for the data loader, for the training data set, right, the 9 files, if it is the batch size is 4, so in one time it will pick 4 files to process. Okay, since it's small data set, we can change the batch size to 1 also. Okay, if it is a bigger data set, so for one time, how many files, training files should be processed, so that batch size we can give here. Okay, so similar way for the validate data set. Okay, you just cache the data set. Okay, for faster experience, and so using this data loader, you can load those files. Okay. So once I run this, then you will be having, like, as I said, this 9 files is loaded. okay, in the train loader, and the 3 files is loaded in the validate loader. Okay. And this is the torch sizes. So this is the height, width. So the batch size, and this one represents the scale, like the width. Sorry, the pixel depth. Okay. So still now, what you have done so far is, yeah, ma'am. Ma'am, any interruption required? Hello.
Someone unmuted by mistake, sir, I think.
Okay. 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 Fine. Okay. So far, what we have done so far is, we just loaded the zip files of images and masks. So, and then we have done some pre-processing, and then we map those intensities with the image mask, because since the image mask holds only 204 distinct classes, so we just mapped with that. And then we just loaded, we just partitioned the training data set with the test and the validate data set. Okay, so 9 is the training, 9 will be in the training, and 3 will be in the validate set, right? So, and then, so here we are choosing the network. So as we discussed, right, like the MONAI framework, the starting will be having the load data, and then so the data should be pre-processed, and then so we have to feed it to a network, right? So the network, what we are choosing is UNet. Okay. So since the spatial dimensions are 2, as we know, right? That is height and width. Okay. So the dimensions are 2, and we can choose the in channels and the out channels. And the out channels must be the number of classes. The number of classes, what you have extracted, right? That is the 204. So this value should be in the out channels. Okay. And then we can specify uh, uh, the different number of channels. Just like it goes like 2 to the power of n, like 2 power 4, 2 power 5, and so on. Okay. So if number of channels gets increases, then actually this model, how it trains is, if the values go on like 64, 128, and so on, right? It resizes using interpolation and other techniques, and also it will train. Okay, not like the actual image what we feed. Okay, so based on this number of channels, it resizes and it increases the number of files, and it trains. Okay, and also strides, like strides for the height, width, and the depth parameter. Okay, so that is also for used for the interpolation and the resampling thing. Okay, so this model is to be constructed. So, and then we have to find the loss function. So what loss function we are making use of? Like we are using this dice loss function, right? So we are first converting into the true one hot y equal to true. The values will be right, like columns, like true positives, true negatives, like so on, right? So what we'll do is, it just converts the row values to the columns, like by pivoting a table, and then it will places the value as, if it is present, it will place the value as 0 or else 1. So this is converting a one hot variable. Okay, so we have an existing data, so that data to be transformed, like so the values will be in one particular column. So the columns will be placed as a row, sorry, the row values will be placed in the column, and in each column, if the value is present, then it will be marked as 1, otherwise it is 0. Okay, so this is what happens in one hot, right? So this is required for this dice loss function. So we are just transforming the data, right? So once we set the model and we run, and we'll say like whether the model runs on CPU or CUDA. Okay, if CUDA is available in this Colab framework, then it will fix because it is for faster execution, or else it will take CPU. So and then we have the model is ready. Okay, and then we can make use of this model and we can perform the model evaluation, right? Okay. Okay, so here we are performing the dice metric score and post prediction and post labeling. Okay, so and then so this is the the number of approaches, right? Is nothing but setting up. So if you set number of approaches equal to 1 is, so it will scan the entire training data set once. Okay, so we have 12 files in the training data set, right? So it entirely scans one time. So to find how many samples are present in the train data set. Okay, and then it performs some loss function. So it will take as batches. Okay, so it will take image value. Okay, so this images is nothing but the images in the images folder, and label is the mask which is in the mask folder. Okay, it will take all these and it finds the loss function, because we have the ground truth in the label and we have the actual value in the images, right? So and we are finding the losses value, everything. So this step was exclusive for the training, and then we are validating with the model evaluation, like the three. So this will do in all the for the 9 images, and then it will take the remaining 3 images, right, for the validation. So it will validate against the 3 images. Okay, so I'm running this. So I'll be skip like the dice computation skip. So this part I didn't execute because I unable to compute this dice metric, since we need some more elements. So I just resulted in error. Or okay, I'll execute it one by one. Like, since in the last step it was crashed, it does not have memory in the RAM. But if you run this code in any container based, like in AWS, in any EC2 instance with a good powerful CPU, then you can get those visualization and other stuff. Let's launch the libraries initially. So that's why it's resulted in error. So now it will execute. I am loading the files. Uh, and then I'm extracting the images and the masks from the folders. So we're finding the number of images in the images drive and the mask directory. And then we're finding the number of classes, right? Then we are creating a data dictionary, so which maps images and the label. So label represents the mask. And then for pre-processing, we are just mapping the value to index mapping. 0 with 0, 1 with 1. So if no values are present, so the existing values are mapped with the index. Then we are loading the data set for so 9 images for training and the 3 images for testing. And then we are setting up the model. Okay. We're checking for Cuba. So if Cuba is not available, and we are making use of the CPU to execute. Is executed, and so it runs on CPU, and the total number of unique classes is 204, which is in the mask image. So here we are training the model. So it's in the training phase. Then it tries to execute this dice validation. So for this, even a small data set, it takes a lot of time, right? So earlier, while executing, I am getting this dice computational skip. May or may not be, we may get this value, or finally can ends with this computation. So the final thing will be in one particular plot, we'll be showing the image and its ground truth, which is remapped. That is the mask image, and then the prediction level. Okay, so how much is the prediction accuracy? It takes a longer time. So okay, so let it complete. So these are the applications we can make use of this MONAI for tumor segmentation. So earlier and all, what we do is we will be having a lot of training images, and we train using some CNN models or RCNN models, and then we test it. Okay, so it goes even 24 hours, 48 hours for training and all. Okay, so these applications, like we have a preset uh, trained or uh, preset models available, and preset network is there. So on top of the network, you can build your own network by optimizing any some parameters on it. So these framework we will have like uh, so no need to set up from the scratch, right? So we can have the existing base is ready, and we can have whatever optimizations or enhancement on top of it. Okay. So these are some of the applications in MONAI framework, like 3D constructions, everything. So these are the MONAI ecosystem. So we have the MONAI core, which is a base library, open source for training and evaluation. And then we have AI assisted for MONAI label and deployment. Like we can deploy the trained models, what we built, so directly to the hospital premises, and then generative, like so using so generative AI, you can prompt and you can create some. Uh, so generative AI is nothing but prompting, right? So prompting and creating our own set of models. Let's check what we have. So ran. Yeah, here it's skipped again. So if it is skipped, then obviously the next batch will not, the next part will not be executed, right? This is not executed. Okay. Yeah, there is the, that's all from my side, man.
Thank you, sir. Participants, now you can post your queries in the chat box, or you can unmute and ask, sir.
So other AI tools, like we have some NiftyNet is available. That is part of the session, but I'm not covered it. Like we have used UNet, right? The similar way we have like other models also. Uh, yeah. Any other stuff? Yeah, we can use Vivek, right? Multi-models and all also we can use.
Any other questions, participants? You can also unmute and ask. I think there are no more questions, sir. Thank you so much, sir. Thank you for your interesting and very informative session. And the demonstrations were very clear and understandable. I believe it was very useful for all the researchers. Thank you for joining with us in your busy schedule. Thank you, sir.
Thank you, Teresa ma'am. Thanks for the session and being a part of it. Thank you so much.
Thank you, sir. Participants, the next session will start in few minutes. We are waiting for the resource person to join. It will start in 5 minutes. Kindly wait.
Thank you, folks. Thanks for the session.
Let's move on to the next session of our FDP. Join me in welcoming the next resource person, Dr. Joseph Manoj. He is currently an AI engineer at Hexaware, specializing in Gen AI, Agentic AI, data science, Azure, and AI Ops. He holds a PhD in machine learning and data analytics and has contributed to more than 30 research publications in the field. With 20 years of experience in academics and IT industry, including a decade in data science, generative AI, ML ops, LLM ops, he brings extensive practical expertise He has delivered advanced analytics and forecasting solutions across sectors such as sales, marketing, automotive, logistics, hospitality, and healthcare. His current work focuses on building scalable Gen AI based applications, integrating LLMs with front end systems, developing fast API services, and contributing to CI CD pipelines. He has hands on experience in LLM productionization, including RAG systems and AI agents, working with frameworks like LangChain, LangGraph, and transformers. He's also experienced in AWS MLOps deployments, Docker based environments, Python, PySpark, and Azure Databricks, with strong foundations in machine learning algorithms and model monitoring. We are delighted to have him with us today and look forward to an insightful and engaging session. We welcome you, sir.
Yeah, thank you so much for your warm welcome. Good afternoon, everyone. Hope you are all doing good. Can I get some hi in the chat? I just want to know how many of you are actively participating. Hope I'm audible. Can I get some hi, audience, participants? Yeah. Okay. Yeah, that's good actually. Okay. So I'll be starting my screen share. Few seconds. Yeah, hope my screen is visible.
Yes, sir, it's visible.
It's not going good. Yeah, and I just want to check my screen is visible and I'm audible.
Yes, sir, you're audible and
Yeah,
it's visible.
yeah. Thank you, ma'am. So hello everyone, and it's glad to meet all of you virtually. And first of all, I would like to thank Professors Hilton ma'am, Trisa ma'am, and for their invitation, right, and to handle this session. So I'll be handling the session on future of AI-powered imaging, digital twins, and smart hospitals. So I think you all know that, right? So what is this digital twins and how this AI is engaging with smart hospitals and digital twins. You all aware of it? And anyway, I'll give some just a high-level understanding on this digital twins and how can we implement this digital twins in healthcare sector. So this is something I'm going to focus on this session especially. And if you have any expectation, just please ping me now itself. Probably I can also cover that concepts regarding these digital twins. And so mostly, but in real time, how are we going to implement this digital twins and what kind of components we are having? So that's what I have planned to cover. And I'll be showing few simulations, so how these digital twins work. and how, as a business, right, we can monitor these digital twins and how that will help us, right? So this perspective, I'll be moving. And the first one, so this is something I would like to talk about, introduction and motivation. So why this artificial intelligence has, been introduced in this healthcare. So if you look at this healthcare landscape is, growing rapidly in respective to population, and so there are a number of chronic diseases. And of course, so there are shortages of healthcare providers. Providers in the sense, it includes doctors, nurses, and technicians. There are a lot of things. So this is the main aim, right? The AI is powered into this healthcare sector. So this is not to replace the human. That's not the idea actually. It helps human to make the process easier and efficient manner. That's what the idea is. So this is one thing. And another one thing is definitely the data becomes huge now. You take, by simple images like CT, MRI, and PET images, ultrasound images, X-ray images. So there are high volumes of, we are generating, hospitals or healthcare industries are generating a huge volume of images actually. So that is another one reason this AI should be introduced, because through this artificial intelligence, we are able to get more insights, right? If you just think about that, there is no AI, and it is very hard to analyze this kind of images and understand what they are actually. So this is something, another one reason we have this artificial intelligence in the healthcare. And of course, AI is now mature enough to impact imaging. So earlier, right, so we were hesitating, right, to use this AI in the healthcare. So nowadays, even you might have heard that the robo has started, clinical surgeries, fully automated or partially automated. That way, now the AI is mature. And actually speaking, we are moved from image interpretation to intelligent imaging pipeline. So that is another one factor we need this AI. And next thing, digital transformation opens the door for digital twins. That's another one point I would like to highlight. And hospitals are becoming highly connected systems now, right? So these are the few reasons we are supposed to have artificial intelligence in this healthcare sector. And what is the final hook I just want to highlight? The future is not AI replacing humans. But of course, there are replacement, but AI plus clinician and plus digital twin plus smart hospital, so is equal to augmented care. So that is the main focus of this AI powered in healthcare, right? So this is something I would like to highlight regarding why this AI should be in healthcare sector. I would jump on directly into this topic. What is a digital twin? So normally, I would like to highlight few things now, right? So you all know that, right? There is a space station, right? So they are completely owned by NASA and SpaceX, so, right? The different owners are there, right? They are own space station. So how they build this space nation and how they monitor and manage, how do they fix the bugs from here? So this digital twin technology plays an important role. So what I'm trying to say, this digital twin is not a dedicated one for this healthcare. On the other hand, this digital twin is a technology that's been already introduced in different domain like health, manufacturing, etc., and robotics, etc. And here, this digital twin can also be used in healthcare for that augmented care. So that is the idea. So if you look at that space station, they are simulating everything. So complete space, I mean, we have real-time station, or physically we have that station, but they are creating something virtually right here. And then through that virtual, they are simulating something. Suppose if they are going to introduce some new component, or if they are going to predict something in that space station, how this component will work after 2 months, after 6 months, or we are going to introduce this component, and then how the prediction will be, or how the space station status will be. So everything they will be doing from here. They won't go there and check everything. So everything happens here. And then once all the things are success, and then they plan for a space station travel. And then they implement that and they come. But this is what happen normally. So same thing. So what is then a digital twin? It's a virtual replica. Otherwise, we can say it's a virtual model, right? And then of physical objects, or systems or processes that use artificial intelligence to analyze real-time data, simulate scenarios, and predict outcomes. So this is what I told, right? What is digital twin means about. But here, how can we use this healthcare? And I would like to highlight one example at this moment. So in healthcare, real world patient, organ, then device, there are a lot of medical devices out there, scanner and MRI devices, right? CT scanner, many stuffs out there. And technical point of view, talk about the technicians are using many devices. So all are coming under this objects, physical objects in healthcare. Even your hospital system, your hospital building, everything can be considered as physical objects. So this can be implemented using digital twin. And of course, you are able to update or monitor everything using these digital twin concepts. So what is the main idea of using this digital twin in our healthcare? So it allows clinicians or hospital administrator to simulate outcomes, predict risk, personalize treatments, and improve operations. So these are the main ideas, right, behind this, digital twin can be introduced in, if it is introduced in healthcare domain. So if you look at this one, right, we have digital twins revolutionizing the healthcare, right? So now we are moving from, physical to edge and cloud computing. So that's what, see here. So now we are having a real physician, okay, for example, right? So they are monitoring everything, and manually they are checking MRI, and is there any other scan images, right? They are checking, and physically they check, right? And the patients, everything. So that's what happens, most of the areas. So in future, everything will be diagnosed, can be diagnosed, right, using this digital twins technology. So that is the idea here. If you look at this diagnosis of enhancement, you're diagnosing something, right, and as well as you're predicting something, maybe anything, right? You're predicting cancer or diabetic or calcium deficiency in future. Maybe a lot of stuffs are there actually, and real-time monitoring. Real-time monitoring how your heart works actually, pumps actually. So not only the patient, so each and every organ, how your organ works, right? So that can be done using these digital twins. And of course, your drug development. So suppose they are prescribing one drug for the patient, and how that drug will work for in your body, right? So for or in your organs, so can be predicted. So everything can be done using these digital twins. So this is what the idea of a digital twin, and how this digital twin will be playing an important role in this healthcare. I just would like to repeat, it's a virtual model and model of physical objects in healthcare. as I said, right? So patients and organ devices, etc., etc. They are all physical objects. And if you want to get or update anything from these physical objects, probably this digital twin technology can be very, very useful. And through that, so this healthcare sector players can simulate anything as well as prediction, as well as personalizing treatments, improve operation. So this is something I would like to share about digital twin and its role in healthcare. Okay. So next one, as I told, right, I have already highlighted this one. So digital twins help in early detection of disease and personalized treatment, safer surgeries, optimized hospital operations, predictive maintenance equipment. And here I have given one simple image. So how this one actually? So this is the physical object, and you can call it as, we call him a patient. And the real-time data will be passing into the model actually. So this is what our twin, digital twin. So here you can call him as a physical twin, right? So his real-time data will be sending to this digital twin. It's a kind of model. It's a kind of model of these physical objects. And with the date and time, so all the things are passing into the digital twins. And in the digital twins, right, there are a lot of functionality components. So that functionality components will be working on that data. I could say that the component is called as AI. So in high level, I'm talking about artificial intelligence. So if you deep dive into it, probably you can use any kind of machine learning models. You can use, up to latest LLMs, right? You may try to implement that functionalities, even deep learning models, right? If possible, ML models, right? So there is no restriction. And this AI will be playing in that functionality. And based on based on the result, based on the process as well as functionality, we have to use that model implementation. Then finally, the patient will get some insight. So this is what happens in this digital twin, and how AI will be used in this digital twin. This is what happens actually. Okay. So they are becoming a central part of smart hospitals, AI-driven healthcare, and precision medicine. So if you want to have smart hospitals, okay, in future or not now, live, right? So what, current also, right? So if you want to have, so definitely these digital twins will help you. For example, you know that Apollo hospitals, right? So they are using this digital twins for hospital management actually. So if they want to monitor how many beds are there and want to check outpatients, inpatient, right? So ICU density, everything can be monitored, right? Through these digital twin. If you have to create a model, and then through that model, you can monitor everything, provided you have to pass the real-time data. So passing real-time data, it's a big thing. Probably you can use IoT technologies like sensors or etc., or some real-time data through cloud. So whatever it is. So this is the idea behind digital twins, and where do we use, right? And then what is the ideology, right, to use this digital twins, right? Okay. If you look at this one in healthcare,
Sir, I think your mic is muted. Can you please unmute, sir?
Actually, someone unmuted me. I think they don't like too strong. Okay, that is fine. Hope you're audible, right?
Yes, you're audible now, sir.
That's great. If you look at this diagram, right, as I told, right, I was telling different components. What are the different components we have in this digital twin technology? And as I told, this healthcare base and patient base. So these are the primary actors, right? And they will be taking place in this digital twin. And I told that, right, suppose you are going to monitor one patient or some kind of devices. So that is what that kind of thing will be coming at this area. But here we are monitoring a patient, right? And then who is monitoring that one? So from the healthcare base, probably the doctor or nurse or kind of any technicians. So they will be monitoring this patient base. So that's what I told, two different primary actors in this digital technology. So this I'm talking, what I actually speaking, the way of implementing the digital twin technology in real world. So that's what I'm trying to come out. Right? So wanted to share. Okay. So this patient base will be connected with data repositories, first of all. So that is the first step, right, to implement this digital technology. Digital twin. So kind of patient medical images or prescriptions or any kind of sensor data. As I told, right, the collecting the data from the physical objects, right? So will be, from different data sources. So you see here telehealth, health records, sensor data. So that's why I told IoT can be used for this digital twin technology. It's a big thing actually. It is not a simply can be implemented, but there are a lot of technicians, engineers should be involved. But AI is one of the components used in these digital technologies. That's what. So again, text data or image data, wearable data, clinical data. So these are the various data sources we can get from the patient base. So that should be stored in for particular data repository. So that repository can be a huge volume of DB. Otherwise, you can store it in a cloud storage area. So that way you can start this digital twin technology actually. So once that is done, probably we have to do some pre-processing. Okay. So that is where that's what we are doing in this data warehouse. So, we cannot use that data directly. For example, you have an image. So it cannot be used that image as it is. Something you need to do, process can be done, something vectorized. And you have health records that can be as an image. They might have, take a photo of that prescription and then they load it. So we need to pre-process this kind of data, and probably if need, we have to analyze it, and evaluation based, we have to evaluate it. So there are a lot of stuffs on that should be happen on that raw data actually. So that's what happening in this data warehouse area. So simply saying, just we are managing the raw data, and we are, if it is needed, we are processing that raw data. And there are a lot of processor involved, right? So to understand the data, you may apply these statistics. Okay, you may apply these statistics. And for understanding, you may apply some analytics approach. Okay, you want to understand, right? You may apply that analytic approach. And then probably you may evaluate that data, whether that data is right or wrong, can be useful or not. There are many stuffs are involved actually. Probably again here this classification point of view, if you say, right? So sometimes, so this IoT data comes in. Probably we have to classify the data based on the time interval, or there are different stuffs are actually thing. But one thing here I would like to highlight, if you want to implement this technology for multiple patients, you just think about that level. Okay, here we are implementing, I'm focusing more on a patient, but this should be this repository, this warehouse, as well as this model will be the common component to all the patients. Okay, so that way, just you think about it. So that is the reason we need to go this data warehouse, data repository process for each and every patient. So once that is done and that data are ready actually, so that patient raw data are ready now, and they can apply, the machine learning algorithms or AI algorithms can be applied on that data. So as I told, you are predicting a lot of things, right, from that data, right? So that is the reason probably you can use this machine learning for digital twins, and then algorithms should be used, and the predictive models, model tuning, forecasting models, intelligent automations. So these are the various concepts can be implemented. So what is this predictive models? Right? So classifications as well as regression algorithms and a lot of deep learning algorithms. So forecasting models in the sense, probably you can use time series algorithms. A lot of algorithms are there. Actually, you can use that one. So this is what the third component, machine learning algorithms. So here I have given machine learning. Probably this machine learning algorithm can be replaced with any kind of thing. I mean, deep learning or our LLMs or LCM. So LCM, this is a large concepts model. So there are, but I could say there is no dedicated model. Don't think that way. So we should have some dedicated model LLMs, not that way. So I'm not going to talk about that one, but if you want, I can highlight later. But here, AI means we are applying deep learning or LLM or any other stuffs actually. Okay. So these doctors, right, they are, as I told, it's another one component, right? So through what they are monitoring this patient is. So through some medical application or any other artificial intelligence UI, or through mobiles or any other gadgets, or to teletherapy. So there are a lot of steps. Not only that, and probably they may use chatbot items. Okay, or robotics can use that one. So this output can be used, right? And then emergency medical service. So there are different domain you can apply this digital domain, and then this insights can be given to these different areas. That's what I would like to say here. Okay, I'm moving next slide. Yeah. Okay. So I want to elaborate the same thing actually. Okay, here I told a digital twin and a physical twin. So now the physical twin is what called as our patient or any kind of medical objects. So they are physical twin. And how they are interacting with each other, and what is the component we have at digital twin as physical twin. See here, this physical twin, they are directly interacting, and what kind of data they are sharing. I mean, sensor hardware providers are there, and through them they are sharing the data. I mean, physical twin sharing the data, and here facility employees are there, right? I mean, some human beings will be there. So through them we are able to share the data to the digital twin. So if you want to speak, you please, otherwise go on mute. Okay, thank you so much. Okay, just see this. And I told you this is a reference architecture. So you see this one, this digital twin. Just think about it. It's not a single person, right? You see this digital twin can be connected with research institute. For example, one medical institute is there, and we have built one digital twin, and that can be used by providers, right? Providers in the sense service providers. I mean, the doctors, nurse, or any other technicians. They can use this digital twin. They are the user. And another one is the research institutes. Suppose someone is doing some research in that same organization, and they need the data. They can also use this one. So these are the different users as well as reference models to implement our digital twin technology here. So we should not strict more on, okay, one patient, he will be monitored by the doctor or nurse, someone, not that way. So this is the component. If you build this digital twin, can be used by any kind of providers or users. That's what I'm trying to say here. So some other vendors or providers, I mean users or data providers, someone may need the data from the digital twin, right? So they can use this digital twin and they can get it. Again, DD developers, and probably if you, biosystem engineers, advisor. So there are multiple users can interact with the digital twin, and they can get the insight from it. Okay, good. So I'll be moving on. So digital twin end-to-end process flow. So already I have highlighted this one, but anyway, I'll be talking clearly about the way of implementing this digital twin environment. So there are, 4 different environments. One is data acquisition layer, and from there, right, we are moving to data integration and pre-processing layer. And third one will be patient model consultation layer. And third one is decision support and clinical interface layer. So these are the different layers we have in this digital twin. Okay, what is this data acquisition layer? So as I told, right, suppose physical objects, maybe patient or devices or anything. Okay, right. Then the images of medical images like CT scan images or X-ray images or any kind of images, right? ECG, EHG, right? Anything. So they are the data, and we need to collect all the data regarding that particular implementation. Suppose you are going to create a digital twin for heart model. For that heart disease identification model, if you are going to build one digital twin, probably you can do that, right? And then so this data acquisition layer will be taken care of that actually. So we have to collect all the data regarding the particular application, what you are going to implement, right? So that's happening in the data acquisition layer. So that is coming from different data sources, as I told, right? Wearables, right? As well as EHR, EMR data and medical sources, different medical imaging, those sources are there. And you are collecting those data, right? That is the first layer you are having in this architecture. And next thing is we are moving to next layer, data integration and pre-processing layer. So what is this data integration and pre-processing layer? Probably we have to normalize the data and imaging pre-processing, like we have to segmentation, or is there any signal filtration? Everything we have to do in this region, this layer, which is called as data integration and pre-processing layer. So that's what here, it is same thing repeating. Real-time data ingestion happens actually here. Okay. So next thing is patient model construction layer. So patient model construction layer in the sense, for example, we are going to build one digital twin for a patient. So we need to create a model. Probably it could be 3D model. So we need to build, create a model for that particular patient. Or if you want to focus more on particular organ, then of course we need to build or design a 3D model for that organ actually. Probably it's a heart or lungs, livers, kidney. There are many organs out there. We need to build a model for that actually. Model in the sense it's a 3D model. It's a kind of design. Okay. So that is done again. Once that is done, mainly this is what the patient model construction layer here, where the complete functionality happens at this area. For example, you see these are the few things: physiological simulation or blood flow simulation, heart electrical activity, right, and lung ventilation simulation, right. So what is this actually? This process, right? So physically, you are unable to test or check everything with the patient. So if you want to some ventilations simulations, or if you want to increase or decrease the simulation, right? What happens? So we cannot test it directly with the patient, right? And then tumor growth prediction, right? So what is this tumor growth prediction? So already that the patient is diagnosed with tumor, and then we cannot wait for, okay, we will see after 2 months, 3 months, not like that. So we have taken that particular tumor, brain model, and then we will be ingesting some factors or data, and then we will be monitoring how the tumor will grow. And again, this one can be explained in different manner. We are medicating the particular patient for a tumor. Okay, the type patient is diagnosed with tumor, and we have to test with some medication. Okay, some drugs. Okay, we are prescribing. The doctors are prescribing. Then how that will be simulate that one. We can test it everything through this layer. Here where we are writing everything, that functionality, everything will be in this layer actually. So how that drug will be react to that particular disease. So everything can be monitored through that. That's what I'm saying. This is one thing, okay, tumor growth prediction or drug response. This is what I exactly I told, right? Drug response simulation. So this is something we cannot test with the patient, right? Instead, we use this digital twin. We create a model, and then whatever we want to test in healthcare, I'm talking about. If you want to test, you can do that. Not only this drug response. There are many things. Suppose you have to, if you want to monitor the heart functionality, you can do that, right? So there are many things, right? You can do that. Okay, again, risk scoring. Again, that's what I told. So how the block will be, right, in next 2 months or 3 months. So okay, if it goes like this, there are cancer is diagnosed, and then what will be the risk? Okay, after 3 months, 4 months. So there are many things happen. So what if scenario testing, treatment optimization, outcome prediction. So these are the various stuff can be implemented in this layer. So this one treatment optimization in the sense we prescribe some medicines, right? And then you are simulating, that drug response. Probably you may find out that that response is not proper manner. It's not up to the mark. Probably you can optimize your treatment. You can go with different direction. So this is what happens here. Actually, what I'm trying to say, this functionality will be written in this functionality layer, which is called as patient model construction layer. And last one is your output layer, decision support and clinical interface layer. So interface can be anything. As I told, right, probably you may develop some web browser, right? And then you may check everything through that user interface, or mobile devices, or any other physical devices, right? You can use that one. So for that, so here some few things are already I have given, right? IoT gateways and Kafka. So these are the few technologies, right, for streaming data, to get the streaming data, and et cetera, et cetera. So that's the reason mentioned like this. But outputs, personalized dashboards, that's what I told, right? So suppose we are monitoring not only one patient, so there are a lot of patients can be monitored. So personalized dashboard can be created, and then predictive alerts. Well, there are a lot of different stuffs can be implemented using this data. That's what I'm trying to say. So based on the data, we can implement this one. So drug dosing recommendation. Suppose we are getting, so you are simulating the drug response, and this doctor is receiving the recommendation from this digital twin, and then he is seeing, okay, this dose is probably we need to increase the dose, or we need to decrease the dose. That kind of recommendation this will get. Okay, so there are lot of things can be done using this digital twin in this healthcare. But only thing is, right, so at least we must know this one. So as I told, this is a reference architecture, and these are the few components, right? And we will be moving to next one. So I would like to talk about a few things on real time. Okay. So this is lung digital twin for COVID arts. So this is one example, right? Used by, so already this Cleveland Clinic or Dassault Systems. So already they are using this digital twin technology, and they have implemented already this one. So what they are doing actually, they are getting the input as chest CT and ventilator parameters, blood oxygen levels. So these are the inputs to this system, to their system they have implemented. And what they are simulating. So lung ventilation distribution, how the lung ventilation, I mean, the distribution is there. They supply blood oxygen, right, into that. I mean, so you just think about this is not they are not doing everything in the physically, right? Just think about that way. They have already created a model for this lung digital twin, and then they are simulating. So, for example, one patient is admitted, and because of COVID, he is suffering, right? And then they will be using this digital technology and create a model for his lung. And then they will be supplying input through their model or through their system to that model only. Okay. Then that simulation will help us to take a lot of decisions. So you see this precision ventilation, avoid ventilator-induced injury, and improved oxygenation and survival. So this is one real-time use case that can be implemented here. So this is what I told. Look at this. It's a 3D model, all right, that is been already implemented. And so this blood oxygen level, right? Already this model is AI functionality is already built. And then this guy, I mean, getting some oxygen flow, right? And then this is predict ventilation requirements, everything will happen here. And then through somewhere, I mean, right? So this digital twin will be updated actually. So see this one, if you look at this one, here the input will be, as I told, chest CT, ventilator parameters, and blood oxygen level, right? So this output will be getting through this device. So what is the oxygen level particular for a particular patient? So this is what happens in this real-time case actually. I would jump on next one. Okay, this is quite interesting actually. So ICU digital twin for bed management. So this is what I told. So hospital, I mean Apollo hospitals and NHS Trust UK based hospital, they are already using this hospital hospital digital twin platform already. So through this ICU digital twin, they are able to monitor different thing actually. You see this used by Apollo Hospital and digital twin tracks, ventilator availability they are able to monitor, and they can monitor nurse workload and patient deterioration score, medication and oxygen usage. Everything can be monitored using this bed management. Okay, and next thing is, what is the predictive output? So when beds will free. So probably we can monitor that also. And any questions? Okay. So which patients will need ICU escalation, right? So you just don't, no need to sit near patient, and if it is needed, or we need to escalate the ICU, something, no need to do that one. So from a single desk, we are able to monitor this customized. So you are seeing one customized device, right? UI. So from here, we are able to monitor the patient's actual status, whether that patient need any escalation, right? Or he's doing good or not, right? His status is going critical or not. There are many things. And there are a lot of, I'm completely, all the beds are full in that particular ICU. And what about the oxygen shortage? So these are all, the main things, right? In a hospital infrastructure we need to have. But if you implement this digital technology, it is very easy way, right? To manage everything, and also the effective manner. So there will be no much human interaction. Of course, the human will be monitoring this one, but all the alerts right? All the notification insights we will be getting through this digital twin options. Okay. And of course, the outcome, better resource planning and improved patient safety. So this is what. So likewise, we are able to implement this digital twin in different applications, different use cases in our healthcare actually. Uh, Probably I'll be taking you to one simulation. So I just want to give some feel. I'm not going to take a complete end-to-end process, but I'm showing this one user interface, right? So same manner, if you want to see, I just want to simulate that one using some other tool. That's what my plan actually, so that you will be getting, okay, what is output of this digital technology, digital twin technology, right? And where are we applying this one? You may feel that one. So that is the idea. I just would like to share other screen. 1 second, I stop share and I'll pick other screen and share with you again. So I'll be preparing that screen. Okay, let's start share. Okay. So hope my screen is visible. Okay.
Yes, sir.
Yeah, thank you. Okay. So I'm using one cloud application. Actually, it's a simulation tool, right? I told one application Apollo hospitals using, right? They want to monitor their waiting room. So it's not a kind of monitoring through CCTV actually, right? This is something, okay, monitoring and how far outpatient comes in, and then uh, different things, right? Whether the crowd will be managed, right? So many things will be monitored. I would like to give two things here. First, we will see this hospital waiting room. This how this usually. Wait a second, it is loading. So see this. Maybe I'll go with 3D. Okay. So this is what actually they are experiencing from this digital twin actually. See, as I told, right, Apollo hospitals are using for complete management, but this is only for waiting room. Okay, and this is what I told, right? We have to simulate first of all the 3D model for our physical objects, right? Not only the patient, as I told, physical object can be anything, right? And if you look at this is what the actual model and how they are coming. And so these are, I mean, probably you see these are all doctors and how each and every doctors are engaged with this. So this is kind of, insight they are getting through this user interface. Okay. So you may think that, okay, we may monitor everything this CCTV. It's not that way, but different stuff. So you see this statistical point of view, right? There are many things you are able to do that, and then see this is what model and logic, right? Okay. So if you look at this logic, actually, this is what I told. One patient comes in, for example, okay, just assume that, right? And probably we'll be talking about different examples. So someone goes to a supermarket, and how the pattern will be. Okay, so that's what I would like to highlight here. This is not monitoring, yes, simply the waiting room. What is the pattern actually, patients are follows here, right? That is something you will be getting as an input here, inside here. Simple example, right? I may say one, customer goes to a supermarket, and then that supermarket finds one pattern. Whoever buy milk as well as egg, they also buy bread. So this is kind of a pattern actually. Right. So based on that, they will keep all the items, nearby. So this is what I'm saying. So what is the logical flow in this hospital waiting room? How they are managing, right? If there is any issue happens, so that way we are able to, get the insights from this, right? And again, this one. So this is a 3D image, same thing. So this is one application, and probably what I'm trying to say here, suppose if you want to but here this simulation doesn't allow me to give the input actually. That's what I'm trying to say. You can experience that how the model or digital twin works in this, but probably I can give you another one example. Okay, this is heart oscillations. Okay, I'll run it. 1 second. Just refresh it. I ran it. That's the reason it's not coming up again. Experiment 1, experiment 2. Yeah. See, I'll be running one simulation now. This is for heart oscillation. Okay. 1 second. 1 second. Okay. So we'll carry on. So you all know that, right? What is heart oscillation, right? So just assume that we are monitoring one patient. 1 second. Okay. So some patient heart oscillation, right? So you know what is oscillation? It's a kind of you are referring or you are monitoring the fluctuations in heart rate actually. How your heart rate is. See here, this is what the heart rate of the particular patient. So you must know one thing, as I told again and again, I'm telling this is you are getting the data from patient, right? Right. This is the live data. You are getting the patient, and it's a kind of ECG, right? You are getting, and then that data will be passing into this model actually, right? That model will be predicting this one. So how it goes, actually, the fluctuation happens, how it happens, whether it is normal, I mean, it's a healthy oscillation, or it is somewhat complex stuff, right? So there are a lot of things can be monitored here, right? And what I'm trying to say, I just increase these two values here, okay? Then this is where the actual process comes into this play, actually. And we are getting this actual data. And what happens if I increase this EPS value? It's actually speaking, so this EPS, it's a value, frankly speaking, I don't know this, right? But increasing these values, so how the fluctuations will be, what fluctuations will be. You see here, it is getting slow. Hope you are able to see, right? Okay. See that marks actually, the fluctuations is getting decreased here. Okay. So similar way, all right. So you are able to, this is what I told, this is what the functionality action we have to do. So here where we introduce AI, in this point, we are introducing the AI actually, right? AI will be getting these two inputs, and already we have built AI models or AI components using any different, I mean, machine learning algorithms, right? So that will predict this value actually. See this now, the fluctuation again getting different, right? Now you see this different one. So this is the manner you are able to understand the particular patient heart fluctuations, right? And you may easily get some insights. Okay, what kind of symptoms he'll be having, or why this sensation, if we increase this EPS X0, what happens? So then it's a kind of simulation of that model. I mean, the physical object, right? That organ, right? So then they will be knowing that one. So using this EPS value, X0 value, they will be knowing that, okay, this fluctuation, right, maybe going this way or this way if we are giving. So we have, based on that, they have to recommend some kind of medication. So that's what, okay, they will be trying to do that actually. Okay. So likewise, so we are able to perform many stuffs here. So this is what actually the final product of our digital twin actually. So probably you can use this, I'll be sharing this link. If anyone wants, just go and check different applications, what happens, so that you may feel how this technology works. And I'll be taking again to the, okay, see here, the same website. Okay, you are having a lot of applications. So I have taken only the healthcare. But if you look at this manufacturing, right? So just want to tell you, okay, not only in healthcare, this digital twin, you are able to apply in different sectors. You see that one in IT, games, right? And test models, asset management, finance, defense. There are many areas we may apply this digital twin. So it's what, Industrial Revolution 6.0, this AI powered, that could be the things, right? So if you look at this manufacturing, okay, and so distribution center, how the distribution center will be working, right? And then solar panel production line, robotic production line, right? This is something I would like to share here. And regarding this, and I would like to share two major vendors to look at this IQVIA, right? So they are one of the leading vendors, providers of digital twins in healthcare. Okay. And if you are doing really some research, or if you want to really want to study something, right? Probably you can see different products here. So where are they use this digital twins? And so probably you can use this one for your research area. You see this clinical products planning suite, grant plan. So these are the various products they are owning actually, not only clinical, commercial products, everything they are having. But this mainly this IQVIA is a huge vendor. They'll be taking care of this healthcare. See this patient engagement suite. What is this? I told, right? Complete hospital management, everything. They will be taking care of this. Okay. So this is healthcare area. This person, I mean IQVIA, this guy will be a great vendor. And you see this Schneider. And I told, right, robotics. So in that perspective, right, this guy will be a, the big one, big person, right? So what are the digital twins? Where are they applying? Okay, mainly they apply to simulate robotics. Okay, suppose someone wants to build one robot for particular application, right? So this Schneider, right? So he is a leading vendor, one of the leading vendor. And he will be simulating the particular stuff. Then they finalize the product, and then final configuration will be given. So this is what happens commercially, right? What happens in this digital twin technology, how the things are. Immediately, we won't go directly, to build a robot or like Indian movie, right? We won't go that way. So we will be building some simulation, and based on that simulation, right, we will be evaluating, and then everything is done, then we'll go. So this Schneider is a company name. They are doing that kind of thing. Mainly, just want to highlight that robotic area. They are doing the great things. Okay. So few things I would like to highlight. And this is another one. Yeah. So role of GenA in AI-based digital twins in Industry 5 and evolution to Industry 6. That's what I told. Okay, so slowly this GenA is replacing the existing deep learning or NLP concepts in this digital twin. And then, we are moving into Industry 6 actually. So really, if you want to do some research, right, especially on this, probably you can also read this, how this GenA will be playing an important role in this industrial revolution, right, point of view. That's good. Just is something I would like to share, and I'll be continuing few other slides. Okay. Okay. So I'm sharing my PPT. Is it visible? Or I have to stop share and share it again. Okay. So hope my PPT is visible now.
Yes, sir.
Yeah, thank you. Yeah, I'll be continuing here. 1 second, let me run. Okay. So these are the 5 KPIs to measure digital twin implementation success. So far I have told you the detailed stuff actually, how to implement digital technology, twin technology, and what are the different components need to have, and who are all the actors and players, business users, right? Everything I have told. And so this is something we have to check in the digital twin while we implement. These are the 5 KPIs. Okay. So first thing is operational efficiency. So simply, right, we cannot just, trust the things as it is, but these KPIs are important. Operational efficiency, and how far this is useful for the cost saving. Okay, that is another one, KPI. Okay, you know that what is key parameter indicators. That's what I'm talking about. And then the productivity. How far this gives the productivity good. Right, operational efficiency means probably we may talk about accuracy, right, or effectiveness, right? As a human being, you are monitoring for example, I told, right, one example, simple example, some nurses or some healthcare provider, they are monitoring a particular patient, or it is very hard to monitor each and everything, right? We cannot have a human beings for each and everyone, everything to monitor oxygen, right? Not like that. So from a single dashboard, we are able to monitor. That's what operational efficacy. And definitely this will be the cost saving, right? So already we are talking about AI is replacing human beings. So that's true anyway. But if you look at this healthcare, we are implementing this digital twin technology in healthcare. Just you think about, I have told few use cases, but I could tell you a lot of use cases. Just you do that, Google it. Okay, you will get a lot of use cases where we implement this digital tech twin in healthcare domain alone. I'm talking about. Definitely, there will be a lot of replacement. Okay, I'll be giving another few use cases in next slides also. So definitely that will be the cost savings, right? And then productivity will be increased actually. So as a human being, it is very hard to monitor your patient and getting the data and the insights, whether he is doing good or not. It is very hard actually, right? So this one will improve the productivity, and definitely we have to take care of this product quality. And finally, because you are implementing this technology, this one in a healthcare. Okay, I'll be focusing more on for healthcare. That's what. So this product quality is very, very important. We implement this one in a healthcare, and directly we are involving with the human beings. So that product quality should be good. And then ROI, return on investment. So these are the 5 key parameters we need to take care while we implement digital twin applications in our premise or for our organization. So this is what the thing. Okay. Then, just want to share the research scope, right? And of course, there are a lot of research scopes are there in digital twin. And as I told, right, I don't know, about 150 participants are here. I don't know, all are from computer science engineering background, or I don't know, but maybe if you are in a different background, electronics domain, mechanical domain, CSC domain, right? So there is no restriction you to use this digital twin as well as to do research on your domain. There is no restriction. Of course, we use AI, but that can be managed by you. But it's not a matter of, okay, we need to implement only in this domain. I mean, only AI engineers have to work on, not like that actually. Okay, as I told, right, you are a IoT engineer, right? Probably you can use this digital twin for the collecting data, and you may get some insight. You may publish some papers. So what I'm trying to say, this healthcare domain is probably, right, you may, AI imaging is entering all healthcare sectors now. Okay, that's what in the first slide itself I told. We are moving into intelligent AI imaging, right? Healthcare imaging. So not only the prediction, okay, so this image having some issue, yes or no, not like that, not only that one. So it will be giving a lot of insights from the image. So we are entering into that sectors. So probably you may explore a lot of ideas on that, and you can do the lot of research on it. And probably there is no wonder you can expect some curriculum components will be soon, right? So if we may expect that at that one, so probably focusing on this digital twin will be the good one for this time, and a huge scope for research and publication in this area. I'm sure, I have seen many things, right, while we publish some white papers, right? So on this digital twin, right? So I have come across a lot of things, a lot of research areas are there actually. Okay, and how to optimize this digital twin and how to make the things safer, because I have not talked about a safety point. Okay, how to secure your application, right? That I have not talked about much technically, but that is again another one scope. And as I told, right, it's a cross-disciplinary skill development, AI, medical, IoT, as well as simulation. And industry, academia, collaboration opportunities are there. Probably we may discuss with some other industries. You may do some POCs, proof of concepts for them. That's what I told, right? So you may get some simulation models, and then you may apply your functionality for heart or any organs, right? and which is, we need to focus more on that. So even nowadays, if you look at this one, this cancer is, it's a kind of common thing nowadays, right? So people are spending more money on that. So maybe probably we can focus something on that, and probably that is a possible thing. You can predict cancer. Okay, a lot of stuffs are there actually. So this is something what I just want to share, not only academic, so all the industry as well as academy communities must adapt this technology nowadays. I mean, it's a important thing. So as I told, right, it's not a newly, coming into this market, not like that actually, is digital twin. But this AI powered, probably you can enhance this digital twin more and more. That's what I'm trying to say. And I have already given them some demo that simulations, so how you may feel, right, or predict something using the giving the value. So I just already that I have pinged that website. You just go and check manufacturing area, what are the different use cases are there, and how the use cases can be managed, right, through this digital twin. Many things you are able to manage or check. Okay, good. And AI-powered smart hospitals. Actually, this digital twin, it's one of the technology, right? If you want to convert your hospital as smart, right? Just you can go with that. But this robotic stuff is something coming up actually speaking. This robotic or playing an important role in these healthcare sectors also. It's just few use cases, so for your information. Probably you all know that, right? Anyway, I just would want to showcase this. Something impressed me. So this one, autonomous imaging system. So suppose as patient we go to for MRI and CT, right? You know that, right? What happens in that? So except patient, no one should be there. You know that constraint, right? There are UV rays or right? That will be a vulnerable one for us. So this kind of robo will be guiding us, right? And for a scanning. So it is what called as self-scanning rooms. So no one will be entering. So as a patient, we go and probably this robo will be guiding, and then you may scan yourself, right? That will guide, and so that what happens. So of course, this machine operation will be happening from outside, that you know that, right? But here again, that human interaction will not be there in the particular scanning room. This is probably could be a smart hospital, right? Application. And if you look at this, fully automatic robotic dentist, right? So as a dentist, right? We need to think about whether we need to go with this BDS. We need to study about this BDS or MDS in future. That is what the situation now. So it's not a partial automatic. If you look at this, it's a fully automatic robot dentist. So that guy will be taking care of everything, right? So definitely there will be a interface or interaction. So based on that, it will be working on the particular patient. Okay, orally he'll be doing that one. And this is quite interesting. So this is something robotic scrub nurse. And I think I don't know whether you are able to see that one. So this is the robo actually. This robo helps the doctor to provide, the instruments. See this kind of scissors and knives for the surgery, right? So how it gives means, so he won't ask. I mean, this doctor won't ask, okay, give this scissor. Not like that actually. So, okay. So this robo will be monitoring the real-time videos. You see this one here, right? Based on that, so this provides the particular components. Okay, doctor may need this scissor or knife. So that kind of stuff, this one, robotic scrub nurse actually. So this is few of the things using robotics, right? We are able to achieve. And another thing, you just listen, I mean, AI-powered patient care. Probably this could be a simple thing. right? So we have a lot of deep learning, trained models. So you are able to do what this particular patient is doing, right? So again, right? So can be monitored outside. So this is another one use case. And this is another one interesting thing, right? Smart pharmacies, right? So based on the prescription, this robo will pick the medicines and will deliver it. Sorry, again, I just repeated this one. So these are the few real-time use cases, right? Probably will be mostly, I mean, this robotics will be playing an important role now. So what I'm trying to say here, why I show this one, not only in healthcare. So now another one thing is coming, that Gen AI, right? And then agentic AI, that, right? So another one is robotic AI is coming. Definitely, we'll be having another one V stream soon. So that robotic AI completely takes care of this kind of application. So handling robots, right? Designing robots, everything will be there actually. So that is another one big domain is coming up. So all the manufacturing industries, all the sectors are started to use these robots. So that's the reason. Just I want like to highlight a few things on robots here. Okay. And 1 second, I stop share and we'll go to one. 1 second, I'd like to share a few other things. So probably just check this link. Uh, Start to share again. Okay. So this one, right? I've shared this link. Maybe parallelly you may check other stuff actually. Okay, this one. So really, it's a good source actually to know about different diseases, right? Anatomy of pie system, complete anatomy, bony landmarks, probably specialties, right? Cardiology, dentist. So please explore it. And what is happening here, right? It may give you a complete tour of the particular, organs and what happens here, right? Okay. And maybe, okay. So kind of a learning material, right? Probably you can use this one. Okay. So this one probably you just know about, but they say this tool will be, I mean, AI will assist you to give more, information on this actually. So if there is any abdominal issue, how to treat it, something it will be telling. So something, just go and check it actually. This is another one. Okay, procedures and treatments you see here. What is the procedures and treatments here? A lot of stuff actually. So if you need any images or any data, okay, to build your research component, probably you might check this one. Okay, that's what this idea. Okay, or just I shared it in shader. Generic is fine. Okay. This is what I told, right? This is pharmacy automation market development of, okay, this is already this Tom and Dickinson, these are the companies, they already have this product actually. Okay. So this is how they have implemented this. Okay. You may go and check it here. Okay. This is what I told, right? So one of the interesting point is, so this is what I told, right? Fully automatic robot dentist performs world's first human procedure. Just think about it, right? And see the result of it actually. Nightmare fuel, maybe historic mode dental profession. AI control automation robot has performed the entire procedure on a human patient for the first time, about 8 times faster than a human dentist could do. So see that one. So how far they are accuracy and efficiency. Okay. So this is the way things are gearing up nowadays. Okay. That's all about my session. And if you would like to ask any questions, probably I may stop share. Yes, can go on question and answers. Not only this digital twin, and if you want to share any other stuffs in agents, agentic AI, agent AI, anything may be discussed. All are available or not actually.
Participants, you can post your questions in
Any
the
other
chat
things
box.
you want? Probably anyone is posted. Okay. Yeah, Mr. Vivek Kumar Sharma was asking what is the future of digital twin in coming era. So, right, that's what I told in many areas. So, future of digital twin, right? Need to implement the latest AI components, right? Probably the agents or LLMs probably can be implemented. And you can extend the application, not only in healthcare, right? I told in different domain, we are able to use this digital twin, probably that can be extended. So this, right, mainly these robots can get some insight, and based on that insight, the robot can be acting towards it. So that way, the future will be actually. So that's what I told. Robotic AI is getting boom actually. So most of the manufacturing companies already started to use this robots and to supervise the components and machineries in their organization. So nowadays, I know that the supervisors are there. They'll be monitoring. They'll be checking the values, components, and how they are working. But this robots will be taking care of everything nowadays. That's thing. The things are moving. So probably this twin technology will be there. Already there, but anyway. Okay. See, any suggestions, learning resources for digital twins in the sense, see, that's what I told. Here, there are a lot of things. It's digital twins, it's a kind of, you know, it's an environment you are implementing, right? So you must know different things, probably the data ingestion point, okay, data warehouse, and mining perspective. You need to know a lot of things, and then AI, right? So there is no specific learning materials for that. It's not a kind of implementing agents. It's a kind of not implementing the predicting this patient is having a disease or not. That kind of ML algorithms. We are not building that one here. It's a huge environment we are building. It should be a holistic way. There are a lot of stuffs are involved already. As I told, that's what I focus more on that components. What are the components are involved, right? So that's the thing. Digital, what is that? I couldn't understand until Shafi.
Hello, sir. Am I
Digital
audible?
twinning, yeah, you are audible. Digital twinning, yep.
So actually,
Patenting,
yes, sir. Because when you're looking into the patenting, like for example, if you're looking for a product or not service based, like if you're going for product based, like new products, like innovative or inventive product, sometimes then the problem of patenting comes, right, sir? Because with the help of digital twinning, if we come up with a product, then the patenting will have a conflict, right? So how can we like separate these two concepts? Like which one should be patented, which one will be like a twin product?
See, you are doing, you are getting the intellectual, you are registering intellectual property for your do not use learning. Just assume that I told one robo that is doing, all the dentist operations. So that can be patented. That product, that vendor, right? They are doing the patent on that robo, right? That way only these intellectual property concepts will be working, right? So probably what I'm trying to say, so to operate that kind of application, you may use this digital twins or whatever it is, right? You cannot, no need to say I'm using digital twin, I'm using AI, this model. No, not needed actually. I'm using Python, I'm using Kafka, not needed. So you are going to build one product for this using this digital twin in the sense, probably you can register that product first of all. If that is not available in the market, you just register it, then you can try it. There will be no conflict actually. It's an open source only, right? You have a lot of things on that actually. Hope I answered your question, Anshul.
Yes, sir. Yes, sir. I got your points.
Yeah. Just think about that way in healthcare or in manufacturing or in maybe any other sectors can be implemented this for a product. That way we can think. Okay. Should I wait for any other questions or?
Participants, any more questions?
Thank you, Gopinath sir. Thank you again. Okay. Yes, Jennifer ma'am, then can we wind up or want to continue any other
Yes,
stuff?
sir. Yes, sir. I think there are no more questions. Thank you very much, sir, for your interesting and very informative session on digital twins. The talk was very insightful and informative, and the demonstrations were really useful for all of us. We greatly appreciate the time and effort you took to share your expertise and experiences with us. Thank you, sir.
Yeah, thank you so much for this opportunity, first of all, and shared this info to all of you. That's great.
Thank you, sir.
Yeah. Thank you. Okay. Thank you so much. I'll be logging off. Thank you.
Participants, now we have come to the last session of the FDP. Let's start with the valedictory session. I now invite our respected head of the department and coordinator of this FDP, Dr. Helton Zinatha ma'am, to deliver the vote of thanks.
Good evening to all, respected dignitaries, esteemed resource persons, dear participants, and my beloved colleagues. It is indeed a great honor and privilege to propose the vote of thanks on this special occasion, marking the successful completion of our 6 days online ATAL FDP on recent trends and future directions on AI for medical imaging. First and foremost, we extend our sincere gratitude to ATAL, the AICT Teaching and Learning Academy, for selecting us to conduct this FDP. This opportunity is truly meaningful for us, as it is the second online ATAL FDP organized by the Department of Information Technology, St. Joseph's College of Engineering. And we thank ATAL for their trust, support, and recognition. And we express our heartfelt thanks to our Honorable Chairman, Dr. Babu Manoharan sir, our Managing Director, Mr. Sashi Shekhar sir, our Executive Director, Ms. Jessie Priya ma'am, our Principal sir, Dr. Vaddi Seshagiri Rao, and our Dean, Lata Selvi ma'am, School of Computing, for their continuous encouragement, guidance, and unwavering support in all our academic endeavors. Their collective leadership has been the strongest pillar behind the success of this FDP. I sincerely thank Dr. Teresa Jennifer, Associate Professor, and my colleague and coordinator of this FDP for her unwavering support, meticulous planning, and dedicated effort in ensuring the smooth and successful organization of this program. Our sincere appreciation goes to all our distinguished resource persons from various academic institutions and industries, including foreign experts, whose presence and contributions have added immense value to this FDP. Each of you has enriched the sessions with deep insights, real-world expertise, and inspiring perspectives. We sincerely thank. I list out the resource person names. Dr. Inbamalar, Professor, RMK College of Engineering and Technology. Then Dr. S.K. Lavanya, Assistant Professor, MIT Campus, Anna University. Mr. Hari Krishnan, Scientist, CDAC Chennai. Then Dr. Hemlada Kanyappan, Faculty, University of Massachusetts. Then Mr. Sai Satish, CEO, Indian Service. Dr. S. Prela Selvi, Professor, School of Computing, Satyabama Institute of Technology. Kritika, Dr. Kritika Balakrishnan, Postdoctoral Research Associate, University of Illinois, College of Medicine, Rockford. Then Dr. Jones Sam Mertens, Assistant Professor, University of Catania, Italy. Dr. Suganya, Consultant Dermatologist, Rela Hospital. Dr. Suresh Kanyappan, Senior Software Engineer, Data Flow. And in today's session, Dr. R. Joseph Manoj, Senior Data Scientist, Hexaware Technologies. And we are truly grateful for this time, effort, and insight each of you contributed to make this FDP an enriching and impactful. Finally, a special thanks for the wonderful participants who have turned up in such a great number from different colleges and universities throughout India. Your support made this event more successful one. Finally, I extend my warm appreciation to all our team members and colleagues who have worked behind the scenes to ensure the smooth conduct of this program. Once again, my heartfelt thanks to each and everyone for your valuable support. Thank you.
Thank you, ma'am. Participants, I have posted the feedback link in the chat box. Kindly fill the feedback form. There are a few instructions for the participants now as we are going to proceed to the test session and the feedback session. Let me read out the instructions. Participants, please complete the test in the ATAL portal. In case you are not able to attend there, kindly wait patiently. We will provide you with the Google form. You can complete the test in the Google form, but the test is compulsory. Next, we would like to have your feedback. So you can post all your feedback in the chat box now about the FDP, and you can also send your feedback in the WhatsApp group. We will enable the WhatsApp group. We will open it to all the participants, so you can type all your feedbacks in the WhatsApp group also. And even now, those who are interested, you can unmute, and by switching on the camera, you can give your feedback to us now. Or you can record at your home, record a video and send to us through WhatsApp. Those who are interested, you can send your video feedback to us through WhatsApp, or you can even unmute your mic and camera and give your feedbacks. And the last instruction, a very important one, we need to process all the 6 days attendance and the test marks. Only then your certificate will be generated. So we need some time to process all the 6 days attendance and then your test marks also. So kindly wait patiently. You will receive your certificate by next week. Thank you, participants.
Excuse me, ma'am. Hello,
Yes, sir. Yes, sir. Please.
ma'am. At what time it will start in that ATAL FTP? Is the link active, or we have to wait till the time what you mentioned in the brochure?
Wait for a minute, sir, please.
Okay, ma'am.
Participants, your quiz link in the portal will be available after 10 minutes. We have set the time. After 10 minutes, your quiz link will be available. It will be active for 24 hours. Your quiz link will be available after 10 minutes. Kindly wait and check. If you're not able to do the quiz in the portal, do not worry. We have Google form. We will post it. Kindly wait for 10 minutes and check in your portal.
Can we get the materials of the sessions, ma'am? Like the first introduction session and the session which was handled by MIT, ma'am.
Sure, ma'am. All the sessions, recordings, and materials will be shared with you through email before Monday, ma'am.
Ma'am, can you hear me?
Yes, sir.
Ma'am, just one question. After fill up this feedback form, I have to give the examination, right?
Yes, sir.
So that examination, basically, you have told me before that that will be happened on 6:30.
Sir, you can attend at 6:30 also, or you can attend in 10 minutes. It will become active. So you can attend earlier also.
Okay. If I want to attend on 6:30, that time I will have to go by this means by Google by this meeting link, or have to go by ATAL portal.
Through ATAL portal, you can check, sir, but the portal will be slow because everybody will be trying to attend the test. Not only this FDP, all the FDPs which are ending today, everybody will be trying to attend the test. So it might be slower. That is why we have the Google form. So if you're not able to attend the test in the portal, we will post the link in the WhatsApp group and you can attend the test from there, sir.
Okay, okay, ma'am. Thank you. Thank you very much.
Thank you, sir.
Good evening, Teresa ma'am. I tried to give feedback, but it is saying, the coordinator should actually update the attendance, and afterwards I will be able to submit the feedback.
Yes, ma'am. You cannot submit the feedback now in the ATAL portal. We want your feedback in the chat box and in the WhatsApp group, ma'am. Today's attendance has to be processed, and we'll process all the 6 days attendance by next week. Only then you will be able to give feedback in the ATAL portal. For now, you can give your feedbacks in the chat box as well as in the WhatsApp group, ma'am.
Okay, sure, ma'am. Thank you, ma'am.
Thank you. Participants, when you are waiting for the test to begin, those who are interested, you can unmute and give your feedback to us. Kindly unmute your mic and video, and you can give your feedback to us.
Excuse me, ma'am.
Yes, sir.
Ma'am, I'm unable to get the test assessment link, ma'am. There's actually the previous FDP assessment links are only available in ATAL portal.
It will start in few minutes, sir. Kindly wait.
Okay.
Or else you can fill in the Google form that we will post. After waiting for 10 minutes, we will post the Google form. You can complete the test there, sir.
Okay. Okay. Okay.
Good evening, ma'am. I'm Kanya from MJ University. I'm heading IT department. It's really wonderful topic and wonderful speakers. You have choose very good topics and speakers, ma'am. Really excellent one, especially digital twin. Today it was a wonderful session. Thank you for this opportunity, ma'am. Thank you.
Thank
Hi,
you.
good evening.
Ma'am.
Yeah,
Yes,
good
ma'am.
evening. This is Raisha from Info University. So the sessions were really good, ma'am, and the times were also somewhere we could set out from our work and then we could work on it. However, today it was 2:30, still somewhere we could join. It was really a good session, and even the hands-on sessions were really good. Every speaker, it was worth attending these sessions. Yeah, expecting something more in communication. I'd really like to join the second conversation. And one more thing, what I would like to ask is that can I leave the session because I think in the after right, directly I have to do it from other end, right?
You're asking about the test, ma'am?
Yes, the test.
Okay, ma'am. What are you asking? I couldn't hear you.
Can I attend it from home? I mean, right now since I'm traveling, I can leave the session, right?
Yeah, you can. You are in the WhatsApp group, ma'am.
Yeah,
Yeah, we'll post the form link there, ma'am.
yeah, sure. Thank you.
So you can leave, no problem, ma'am. Thank you for your feedback, ma'am.
Thank you so much.
Ma'am,
Yes, sir.
ma'am, it was really very nice session, and speakers was really very much. They have whatever discussed was very innovative for us. It may be possible that you please send all the detail in the drive, then we can easily access the data what they have told there.
Sure, sir. Sure. We'll give all recordings of all the sessions and the materials shared by the resource persons also to you, sir. Thank you for
And
the
session
feedback,
was
sir.
really very innovative.
Participants, the test link has been posted. Try in your ATAL portal. If you're not able to access your ATAL portal, you can use this Google form to attend the test.
Hello, ma'am.
Yes, ma'am.
Ma'am, the assessment is not open on ATAL portal. But actually, I mean, as per my knowledge, we have to write the test on ATAL portal only so that we get the certificate. Is it okay if we write it on this Google form also?
It's actually open for everyone, ma'am. I don't know how it's not. It was open by 5:15 itself. It's
But
open.
here,
But if you are not able to do the test in the portal, then you can use the Google form. We'll update the marks in the ATAL portal, ma'am.
okay, fine, ma'am. Because in the ATAL portal, it's not showing the test
You
link is not.
can refresh or close the page once again and try in, ma'am. Try
Ma'am,
for you can try once again. If not
ma'am,
possible, you can.
ma'am, in left side, the assessment, it's given, it's showing only. You can attend the test.
Yes, for all the participants, they're able to attend, ma'am. Most of the participants are attending through ATAL portal. If the
Okay, ma'am.
portal
I
is
check.
slow,
Otherwise,
if the portal is slow, then we accept the
Ma'am,
Google
it
form
is
answers
very
also.
slow, ma'am. It's not going on to the next thing. So we started in the Google form, ma'am. Is it
Okay, no
mandatory to
problem.
go in ATAL?
No problem, ma'am.
Thank
You
you.
can
Thank
complete
Okay,
the
ma'am.
test on Google form.
Yeah, okay, fine, ma'am. Thank you.
Thank you.
Madam, excuse me, madam.
Yes, sir.
Ma'am, I opened Atla portal, madam. Open the attendance link, but status is attendance not updated, madam.
Yes, sir. Today's attendance, all the 6 days attendance will be updated together only, sir.
Yeah, madam. Okay, thank you so much. Right.
You can attend the test there. Attendance will be updated by next week, and next week you'll receive your certificate, sir.
Okay, ma'am. Right.
Participants, try to attend the test in the ATAL portal. If it's not possible, you can attend the test through Google Form. Thank you all for your cooperation. We are going to close the meeting now. Thank you.